Hello all, I, Dr. Nidhi Sharma, Assistant Professor Chemistry, AISSMS, IOIT, welcome you all for today's lecture. Now today I am going to start the IR spectroscopy part 2. In IR spectroscopy part 2, we are going to discuss about the instrumentation of IR spectroscopy. So first, as you can see in the given figure, this is IR spectroscope. It is the spectroscope which works like the UV spectroscope only. There are two type of IR spectroscope: dispersive grating spectrophotometer and multiplex instrument employing Fourier transform. So as this infrared is an absorption technique, so what happens? This infrared radiation passes through the sample and it is detected. In this way it is going to work. Now how it is different from UV visible? The configuration remains same in UV visible absorption spectrophotometer except the light passes through the sample before reaching the monochromator. In UV visible spectrophotometer, the first light passes through the monochromator and then passes through the sample. But in IR spectrophotometer, the first light passes through the sample solution or through the reference solution, and then after that it passes through the monochromator for getting the single wavelength line. That's how it's going to work. Rest, the placement of chopper, the placement of reference, the placement of sample solution, it is in the same way. As you can see, there is a IR source. So IR source, these are the mirror which are placed to change the direction of IR radiation. First it is passed through the reference solution and then it is passed through the chopper, and from chopper it goes to the monochromator and finally to the IR detector. And then after that the radiation passed through the sample and then we get the IR data ratio, and then finally we get the result. So as you can see, this is another diagram: IR source, the reference, the sample, the splitter, the detector, and finally we get the readout. So one by one we are going to discuss the important component of IR spectrophotometer. The first is the IR source. In IR source we can use nursed filament, globo, incandescent wire, mercurium. So the nursed filament means it is made up of zirconium oxide, yttrium oxide and erbium oxide. The global rod of silicon carbide, tungsten filament can also be used. So these are the different IR sources which can be used. Then after that, the second is the monochromator. So monochromator, prism or grating are used as monochromators. They are used to select desired radiation frequency. So prisms are normally made up of metal halides like sodium chloride, potassium bromide. So why these prisms are made up of metal halides? The reason being because IR radiations cannot be absorbed by these metal halides. So that's why the prism can be made from sodium chloride and potassium bromide. Okay. Now the next part is the sample cell. Sample cell and sampling of substance. IR spectra can be obtained from solid, liquid, gas. Material containing sample must be transparent. That is important. So the material made up of certain salts like sodium chloride, potassium bromide, lithium chloride, these are used. Okay. So now next is the sampling of solid. How the sampling of solid can be done? The sampling of solid can be done by solid in solution. So solid in solution means the solid substance is dissolved in non-aqueous solvent. A drop of solution is placed on the disc on alkali halide and solvent is dried to give the thin film or the surface. So it can be done by the solid film technique, it can be done by the pressed palette technique, and it can be done by the mull technique. In mull technique, the sample is mixed with the nuzol, mineral oil and mull to make a fine paste. And then after a thin film is applied on the KBR gun. Now how the sampling of liquid done? Liquid sample can be sandwiched using sample cell, KBR, NaCl. And how the sampling of gases can be done? The sample cell made up of KBr and NaCl can be used for this purpose. And finally, the IR spectroscopy has been used to characterization for any solid, liquid, gas sample. These all three types can be detected with the help of this. Now this is these are the working, how the plates and all the samples are just made, and this is the IR spectrograph which is obtained. Then after that, next is the detector. So what is the role of detector? The role of detector, it converts the radiation into electrical signal. So there are three types of detector: photon detector, thermal detector and pyroelectric detector. These are the three kinds of detector. So generally the thermal detector is used. IR radiation in thermal detector, the thermocouple, thermopile, thermistor, which is also known as bolometer, Gole detector, pyroelectric detector. These can be used. Like suppose if we talk about the thermocouple. So in thermocouple, the two wires of different materials welded together in thermocouple. And one of the two welded joint is hot junction, which becomes hotter because of IR radiation, and then other joint is cold. So a small electric potential develops between the joints due to this temperature difference. So the resulting current is directly proportional to the IR radiation falling on detector. So in this way the thermocouple is used. Like suppose if we talk about the bolometer, so platinum or nickel is used in the bolometer, and it is a type of resistance thermometer used to detect the measure of weak thermal radiations. With the help of bolometer, the weak thermal radiations can be detected, and change in resistance is observed due to the again change in temperature. Gole detector, it is sensitive gas thermometer containing xenon. In Gole thermometer, the xenon gas is used. So in this way, different types of detector can be used. Photon detector, as you can see, the photon detector in that the indium antimony, lead, tin, tellurium antimony. So there are different compounds that can be used for the photon detector. So and finally the amplifier and recorder. So amplifier and recorder, amplify the signal from detector and send to the recorder. So sophisticated recorder give the IR spectra of a compound as a graph of percentage transmission of IR radiation versus wavelength, so, or wave number. So in this way we are going to get the IR spectrogram. Now the region of IR spectrum, the spectra which we are going to get, it is divided into three parts. As already I have told in the advance, the IR region is divided into three parts: near IR, middle IR, high IR. So basic important zone is the middle IR region, which ranges from 2.5 to 15 micrometer or 4000 to 667 centimeter inverse. This is the wave number. So if the functional group region is detected in the zone which is from 4000 to 1500 centimeter inverse. The fingerprint region, the second region, which is from 1500 to 909 centimeter inverse, and the aromatic region, which is from 909 to 667 centimeter inverse. So in this way, with the help of middle IR region, we can detect the functional group, fingerprint and aromatic region. So one by one, we are going to discuss about these regions. The functional group region, it is the most common application of IR spectroscopy. The region extending from 4000 to 1500 centimeter inverse. It is called functional group region. This part of IR spectrum contains absorption band due to stretching vibration of functional group. Very important part, it occurs due to the stretching vibration. This part of IR spectrum contains band due to the stretching vibration, and it gives the information about the functional group which is present in the compound. Then second is the fingerprint region. In fingerprint region, the region is from 1500 to 900 centimeter inverse. This is called fingerprint region. This is the most complex part of the IR region spectrum and contain number of absorption band. These absorption band appear due to the stretching and bending vibration. This is very important part. that this fingerprint region is occurred due to the both the vibrations, banding vibrations and stretching vibrations. This region is not useful in interpretation, but it can be used for the identification of compounds because it is a fingerprint of the unknown compound. And finally, the third, aromatic region. This region is useful for the detection of aromatic characters of the compound. It provides the information about aromatic substitution patterns such as ortho, meta, para substitution. And the bond that occur in the region are due to the banding vibration in the molecule. So, hence, as it is clear from this, functional group is due to the stretching. This fingerprint is due to the banding and stretching, and this aromatic region is due to the banding vibration. As you can see, this is the spectra, and here the stretching vibration and banding vibrations are there. So this is the region which is from 4000 to nearly 1300, and it is giving the frequency region, and this is the region which is giving information about the fingerprint region. In this way, we can detect the unknown compound. This is again one more characteristics of the compound, like different zones of the IR vibration bands. So now, next part is very important part. This is about the what are the applications of IR spectroscopy. So first application is it helps to determine the structure and functional groups. Like identification of functional groups can be done with the help of this. As we know, there is a functional group region, so it can help to determine the functional group. Different type of functional group have the different absorption frequency. It can identify the structure of the compound. Identification of structure can be done by comparing the fingerprint regions of the different compounds. Then it can be used to study the chemical kinetics. A comparison between the IR spectra of reactant and product can help to determine the course of the reaction and the kinetics of the reaction. Then it can help to the hydrogen bonding. IR spectroscopy gives the information about the hydrogen bonding. Bands due to the hydrogen bonding appears at very low frequency. So it can help in that. It can help to detect the impurities also. Before that, hydrogen bonding, it can distinguish between the intermolecular and intramolecular hydrogen bonding also. The next is the detection of impurities. IR spectra of impure sample will show extra absorption band by comparing the IR spectra of the pure band. So presence of impurity can be easily detected. Then the study of isomerism can be done, like keto-enol tautomerism can be studied with the help of IR spectroscopy. The IR spectra shows characteristics absorption of carbonyl groups for keto, and whereas broad OH C double bond C stretching frequency from enol. So keto-enol isomerism can be detected. Then it helps the determination of size of ketone rings. What is the size of ketone rings? Now other very important applications, like it helps in the analysis of urine and other biofluids like urea, creatine, protein. Quality control of pharmaceutical formulations can also be done by the help of IR spectroscopy. The distinction between inter and intra, already it has been discussed. The measurement of, this is used in non-invasive measurement of glucose. Like measurement of ethanol in breath can be detected with the help of IR spectroscopy by a device called intoximeter. So with the help of that, the alcohol detection can be done. In fact, the measurement of paint varnish can be done by this IR spectroscopy method. This technique can be used for identification of old painting and fake masterpiece also. So that's why very important. And in industry, the IR is used for the determination of impurity in raw material. So thank you all for today's presentation.